Okay, today we're doing money. So when it comes to money, this is the differential equation that you're going to deal with. Let's actually do yellow. Where the plus and minus K is talking about withdrawals or deposits. So if we have a person who places $5,000 in an account that accrues interest compounding continuously, assume no additional deposits or withdrawals have been made, how much will the account have after 7 years if the interest rate, 7 years, if the interest rate is a constant 8.5. So R is equal to change that interest rate from 8.5% into a decimal. And then for the first, so it has 8.5% interest for the first 4 years. Then it switches over and has a constant 9.25% for the last 3 years. Okay, so we really need to split this into 2 intervals. One interval where we have starting from 0 till 4, and R is 0.085. And then the other interval, and time is between 4 and 7, and our interest rate is 9.0925. All right, so now let's substitute. First, we have to start, because the money in the account is starting at time 0, and we have to figure out like how much money is going to be in the account after 4 years to then shift off to figure out how much initial money is in the account when the interest rate changes at 4 years. So substituting into our differential equation, ds dt is equal to RS, so 0.85S. Notice I have no plus K because it said no withdrawals or deposits. Right here, so K is equal to 0. Okay, separate your variables. Integrate both sides. Solve for S. So we would need to raise both sides to the E, exponentiate both sides. And we have the absolute value of S, but when we have this over here, we have e to the 0.085 t plus c really becomes e to the 0.8085 t times e to the c. And remember, this is going to be a constant. That constant could be positive or negative, so that's going to deal with our plus and minus from the absolute value. We'll say it's C1 because we're going to have to integrate when we shift from the time starting at 4. So we'll call this C1, e to the 0. I keep forgetting that 0.085 t. We'll say this is S1 of t. Hopefully, some of you have some Algebra 1 recollection and remember that this is kind of looking like A equals P times E to the RT, PERT. And that was if you were having some kind of exponential function, growth function that was compounding continuously. That's where PERT comes from. You actually need to have some calculus to get PERT instead of just like memorizing the formula. We could actually have some calculus and differential equation skills. All right, let's apply our initial conditions. So our initial conditions is that at time 0, we put in $5,000. So we're going to set C1 equal and then plug in 0 for T. So we have really C1 is equal to 5,000. That means S1 at T is 5,000 e to the 0.085t. So if you do remember this PERT formula, you're doing this on a quiz or a test, you could like know you did it right by the calculus matching the algebra. Just an idea. Then we need to use this formula, to get our initial condition for the time shift. So when does this end? This interval ends at t equals 4. So we want to figure out how much money is in the account at t equals 4. To 4.74. This is how much is in the account at t equals 4. So this is our initial condition on the next part. Now let's basically do the same thing, but with this interest rate. All right, do the same thing, separate your variables, blah, 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 and then you get to here. And use your initial condition from this part. So that makes C2 not be 7,000. Remember, you're going to have to set this equal to C2 e to the 0.095 times 4. And divide both sides by that e to that power. Then we get C2 equals 4,852.23. Okay, so our S2 at T equation, 4,852.23 e to the 0.095 T. And then let's make sure we answered what was asked. How much will be in the account after 7 years? So really the question is, what is S2 at 7? So after 7 years, plug it in, use your calculator. Okay, so this answers the question. If you want to be able to use this, not just for 7 years, but say this problem went, this interest rate was applied beyond just 7 years, you would be allowed to set up a piecewise function. It would be appropriate to set up a piecewise function going from 5,000 e to the 0.085 t. T is between 0 and 4. And then 4852.23 e to the 0.095 t, 4 to 7. That would be that piecewise function. Okay, there's another page, and I really hope by the time you're watching this, I actually remembered to type out the equation on this other page. But this is a type of question that I usually like to do on tests. So when we have a repayment amount. Okay, so let's think. We're gonna say Karen borrows $8,000 for a car with 10% annual interest rate, compounding continuously. The life of the loan is 3 years. What will Karen have to pay the bank or whoever is giving the loan annually? And then same question, monthly. Like, what would her monthly payments be? We'll say that's A. And then part B, how much will Karen have paid in interest during the 3 years time period? Or maybe we'll say after 3 years worth of payments. Okay, so this is when we have to do the ds dt is equal to rs minus k. This is our principal, so the initial amount, and the interest, whereas this is our repayment amount. What was my interest rate? 10%. Try to keep it nice and simple. And unfortunately, these days, a 10% interest rate on a car loan is actually kind of not that crazy. Okay, so we can't do separation of variables because we had that plus or minus k. Oh, and also I want to make note, repayment amount annually is k. So we're going to have to do integrating factors, the magic mu. So move the variable that's matching the variable in the numerator over to the same side. And so mu will be e to the integral of negative 0.01 dt. Remember, we're just taking the coefficient, which means this is going to be e to the negative 0.01 t. So we're multiplying each term by e to the negative 0.01 t. And you see the product rule that's happening. This is the derivative of e to the negative 0.01 t. And then this is the derivative of s. So we have e to the negative 0.01t times s derivative equals negative k times e to the negative 0.01t. Get rid of the the derivative by integrating both sides. Okay, integral of e to the 0.01t, we're going to get divide by negative 0.01, e to the negative 0.01t, plus some constant c. Solving for s means I'm dividing everything by e to the negative t, or we could think of it as multiplying everything by e to the positive 0.01t. So we have k over 0.01, which is really the same thing as k divided by 1 over 10, multiplied by the reciprocal. Okay. Then we have to think about our initial conditions and our buy condition. So our initial condition is how much money we started with in the account. How much was like the principal of the loan? She borrowed $8,000. Our buy condition, which means just like a secondary condition, is the life of the loan. So the life of the loan was 3 years. What that means is by the end of 3 years, or 36 monthly payments, you will owe $0. So writing our buy condition, we would have S at 3 because our interest rate is in years and our payment amount is in years. S at 3 equals 0. Okay, so plugging into the initial condition, 8,000 is equal to 10k plus c times e to the 0. Okay, let's solve for one of them. I think it'd be easier to solve for c. C is equal to 8,000 minus 10k. Now, use that c, plug into here, s at, but we're going to use the buy condition. 10k plus 8,000 minus 10k times e to the 0.1 and plugging in 3. S at 3 was equal to 0. So we're solving this part and we're going to be solving for k. That was just C that we did. So I'm going to isolate the k's. That means I need to distribute this to both things. So I have 10k plus 8,000 e to the 0.3 minus 10k e to the 0.3 equals 0. Anything that doesn't have a k is going to move to the other side of the equal sign. It's equal to negative 8,000 e to the 0.3. Factor out the k. You could factor out the 10 too, but we're just trying to solve for k. And divide both sides by the 10 minus 10 e to the 0.3. So So we get K is equal to that little negative 8,000 e to the point whatever over 10 minus 10 e to the point thing, which if you use your calculator, you'll see is 3,086.64. This K is how much we're going to pay repayment annually. So this would be per year. So this answers part A, 1. But the second part, what we're going to have to do, think about how we could get it monthly. Because really most people don't pay most people can't just afford to pay $3,000 like right at the beginning of a year. I mean, some people can, but you might not just have $3,000 ready for that. So a lot of people pay their car payments monthly. So let's figure out how we would do that. What would we have to divide by? We have to divide by 12. So you divide that by 12, and I think you get $257.22 per month. Then it was part B that we wanted to figure out the total amount of interest each year, or in 3 years. Total amount of interest in 3 years. Okay, so how much do we pay each month or each year? $3,086.64 each year. That's how much we're paying every year, times 3 years. So 3 times that annual repayment amount. We get $9,259.92. So for this $8,000 loan, we end up paying over 3 years $9,252. So how much did we pay in interest? Subtract the initial principal amount, $1,259.92 in interest. And this is when I know my own father said, that's why you should just save up for a car, save up for whatever. Obviously, saving would help you avoid this interest, and you get the savings account interest rate. But, life happens, things happen, and you might have to get a new car before you had saved up enough money for the new car. Also, with inflation, $8,000 doesn't buy you much of a car anymore. So, you might have to get a loan for that. You might have to get a loan for college. It is important to realize that with every loan comes an interest rate, because banks aren't going to give you a ton of money without having a reason, like any way to any incentive for them to give you the money. So if they're giving you money, realize that there's going to be an interest rate. And at the end of the time when you agree to pay that money back, you will always owe more money than you received from them. So that's on interest rates. Okay.